questions for me? Yeah.
Number 5 on the quiz.
Yeah. So it says, a ship leaves the port of Miami traveling on a bearing of 80 degrees east of south at a speed of 15 miles per hour. After 1 hour, the ship turns 90 degrees toward the south. After 2 hours traveling the same speed, what is the bearing of the ship from port? So, 5, quiz. Get a little diagram going. Now let's put this information on here. A ship leaves the port of Miami traveling at a bearing of 80 degrees east of south. So initially you want to draw your path 80 degrees east of south, so something like this, where this angle here is 80 degrees. Then it says that the ship's traveling at a speed of 15 miles per hour. After 1 hour, the ship turns 90 degrees. So if the ship's going 15 miles an hour, how far has it traveled in 1 hour? 15 miles. So the ship travels 15 miles on this bearing. Then it turns 90 degrees toward the south. So it makes a 90-degree turn toward the south direction. Right, and then it says, after 2 hours traveling at the same speed, what is the bearing of the ship from port? So in this direction it travels for 2 hours, which means it goes how far? 30 miles. Cool. And so then the question is asking, what's the bearing of the ship from port? So it left from port. The bearing would be the angle to this ray here. Since your bearings are usually measured from the south to the north, I would take this as my bearing. In order to find this angle, I would first find the angle in this triangle. Let's label it blue. I would find this angle first. Because if I knew this angle, then I know the total angle here is 80, so I can take 80 minus this and get this. Okay? Cool. So how do we find this angle, which we'll label theta? Yeah, so according to theta, we have adjacent and opposite. So I'd probably use tangent. Tangent of theta should equal what? Opposite, 30, over adjacent, 15. So tan theta equals 2. How do you solve that for theta? Tan inverse. So the tan and the tan inverse go away. Theta equals the inverse tangent of 2, which is approximately 64 point something or something, 63 point something?
63.4.
So you have to type this in your calculator in degrees mode, and it should give you something like 63.4. Now that's theta, but I don't want theta. In order to get the bearing, I need to measure from the south direction. So in order to get this green angle here, my bearing, I'm going to do 80 minus 63.4, which will be 16.6 degrees. So the bearing from port to ship at this point would be south, the S, 16.6, so 16.6 degrees east of south. All right, what else can we do here?
Do number 1.
Find a model for the simple harmonic motion satisfying the specified condition. The object starts at rest, the amplitude is 4 centimeters, the period is 2 seconds. Start at rest. Amplitude is 4 centimeters. And period is 2 seconds. So, what do we got to do? The general formula is either, for simple harmonic motion, the formula is either d equals a sine omega t or d equals a cos omega t. Which one do we want to use here and why? Sine, because it starts from rest. So if you start from rest or if you start from 0, it's the same thing, you use sine. And what's a going to be?
4.
4, because the amplitude's 4. So we know we're going to get d equals 4 sine omega t. And how do we solve for omega? Use the period. Right? You have a formula that relates omega to the period. Right? The period is equal to 2 pi over w, or omega. Since we know the period is equal to 2, plug it in. If you multiply up the omega, you'll get 2 omega equals 2 pi. And if you divide by 2, you'll have omega isolated. So my final equation should be d equals 4 sine pi t.
Can we also do 2?
Point on the end of a tuning fork moves in simple harmonic motion described by d equals a sine omega t. Find omega given that the tuning fork's middle C has frequency of 262 vibrations per second.
I'll eventually figure these out. I just want to see that I did them okay.
So, I'm asking you to solve for omega here, and I'm giving you a frequency of 262. And I'm asking to solve for omega. So how do you do that? What's the key observation here? What's the relationship between frequency and period?
Inverses.
They're reciprocals, yes. So, the period is 2 pi over omega. So the frequency is equal to omega over 2 pi. That's one way to do this. Just flip the formula. So if you do it this way, then you would set 262 equal to omega over 2 pi. Multiply by the 2 pi to isolate omega. 2 pi, 2 pi. Omega equals 524 pi. So that's one way to do this. If you don't like this formula of frequency equals omega over 2 pi, then you could start from the very beginning here by changing frequency into period. As soon as you see the frequency is 262 vibrations per second, then the period is what? 1 over 262. It's a reciprocal always. So the other way to solve this problem would be to only use this formula here and set up 1 over 262 equals 2 pi over omega. So just plug in 1 over 262 here. And then you would have to multiply up the 262 and multiply up the omega. So omega equals the same thing. End up being the same. did you guys get a chance to look at any of the law of signs stuff? I'm going to be answering questions on that next time. Okay, so keep working on the homework. Look at law of signs a little bit at least so you can ask me questions on Wednesday.